Good morning, good afternoon, good evening, depending on whichever part of the world you are joining us today. So my name is Akhilesh Soni, and I have more than 17 years of experience into cybersecurity. I am working at Tech Mahindra as a global cybersecurity leader. So today we'll be talking about Tara automation for safer vehicles, and it's a very interesting topic that we have for today's webinar. So before we start off, so in fact, it would be good to introduce you in terms of the way we have partnered with Plexidity in terms of providing automotive cybersecurity services. So Tech Mahindra and Plexidity both do a lot of work with respect to automotive cybersecurity. So we have tied up hands to ensure that we are able to provide robust cybersecurity services focused around automotives to our customers across the globe. So joining us today is my colleague Ran. So Ran, over to you.
Thank you, Akhilesh. Hello, everybody. My name is Ran Ben-Zvi. I'm a product manager at PlaxidityX, leading our Tara automation solution named Auto Designer. And let's see what we are going to discuss about today. So first of all, we're going to do some introduction to the importance of automotive cybersecurity. Then we are going to discuss what is a Tara, see a case study of creating a Tara, from the real life, of course, to see the challenges of doing Tara manually, see an approach to doing Tara in an automatic way, and of course, later on, a live demo of our tool, our Auto Designer, showing how to automate and manage a Tara in such a way. And at the end, of course, a Q&A session. Okay, so let's start. Actually, why we are even discussing more and more about cybersecurity in the automotive industry. First of all, it's something that the automotive manufacturers themselves are more concerned about. We can see it from a survey from the last year actually, that the cybersecurity risk is the #1 concern of the manufacturers compared to the previous when it was in a different location. It's actually a bigger concern than the supply chain disruption, the workforce, energy crisis, and more. So first of all, the automotive industry identified that as an issue. Also, the regulator identified this as an issue. That's why we can see different regulation worldwide discussing about cybersecurity, especially for automotive, from ISO 21434 to the UN regulation 155. Also in the US, the NHTSA regulation, and in China, the GPT regulation specifying what car manufacturers and component manufacturers should do in order to protect against cybersecurity threats. We can also see that those regulations are going to extend to motorcycle and scooters. Also in India, there are a specific standard currently in draft rate going to be published soon, and also to tractors and more vehicles like that. But this is just, numbers or thoughts and regulation, but we can see it also in the real world as a problem, as an issue with actual business implication. We can see 2 examples for car models that are stopped being manufactured due to new cyber requirements and safety issues. So it's going to, first of all, have a business impact, help impact the brand, the reputation, and eventually have a financial impact. So cybersecurity is a real issue our industry is facing. And how the different startups or things are looking into those issues. So if we will look on the V model that we used to work with in our development, starting with the requirement analysis, the design, and implementation, and of course later on integration, testing, and operation, the regulation is addressing those specific steps with adding the Tara, the threat analysis and risk assessment with security goals, security concept and cyber requirements to the design phase. In the implementation, we need to implement those cybersecurity spec follow the post-development requirements, do, of course, vulnerability analysis for our software. And when we are testing, verify those cyber issues and requirements and validate them and supply a report for that. Today, of course, we are going to focus on the design phase where the Tara security goals and cyber security concept has to be created. So what is Tara? First of all, it stands for Threat Analysis and Risk Assessment. Is a process discussed by the different regulation and defined by it, how to identify the different threats and issues in either a vehicle or component or even a software. The first thing or step that we need to take is to identify the different assets that are relevant to cybersecurity and might have consequences because of cybersecurity. Then, for each one of them, we need to identify the relevant threat scenarios for those and also understand what are the damages that can occur for those assets from the road user perspective. Then we will analyze and identify the different attack paths and realize them based on the threat scenario we created earlier. We will understand for each one of those attack paths what is the risk value and the risk that they are bringing into our system or into our vehicle, to the system that we are analyzing. And at the end, of course, understand how we would like to treat them and define the different mitigation that needs to be taken. And then, of course, we will recalculate the risk. And how this process looks like in the real world when we are doing it in a manual way. We will probably have a security expert that will have to look into different inputs from the design file, the architecture of the system, the requirements, the safety report, the HARA, and the risk management policy of the company, and follow the different steps with that information, from the asset identification to the threat analysis, damage scenario, for example, for understanding the threats or the damages. He needs to look into the requirements and the safety to see what implication it has on the different components. And based on all those steps, it will perform the risk assessment, calculate the risk value, choose how to perform and to treat those, and then we will get the TAR report. But the process does not stop there. Then he will create the cybersecurity concept to the system based on the risk identified, and that we choose to reduce the risk. He will create the requirements and then create the cybersecurity requirements that would be handed over to the development team for development. But the process is not linear. It's not stops here. The process is more circular because the TARA continues to evolve, and nowadays we have requirement changes during the development, even when the vehicle is on the road. We have design changes that might impact the TARA. We have OTA updates, and of course we have vulnerability detected. And just to say that we have a vulnerability, it's not enough. We want to know what risk it introduced and if it changes the value of a certain risk, whether it's for the safety, for the finance of the company, or the operational of the vehicle. Now, this is the theoretical phase. Now, Akhilesh, if you can please show your insights from doing this process in real life.
Sure, Ran. So anyhow, I think you must have got some understanding in terms of what we are talking about. And obviously, if you look into the manual way of performing TARA, so it is always good to look at a real world scenario. So this is a case study wherein we were working with one of our customers who is a leading mobility supplier in the automotive sector. So the customer came to us with real life challenges, which we typically see that tier 1 providers have. So the first pain point that the customer had was they had a backlog of ECUs, which required security verification and validation. Essentially, they wanted us to conduct TARA for these ECUs. And why they had these backlogs? Because the main reason behind it was the manual way of performing TARA. So if we look at conducting TARA manually, so currently if you look into the manual process, it would go about 3 to 4 weeks of time for a security SME to come in and get engaged and look at all the considerations which Ron talked about, and then finish off with the Tara report and obviously identifying the vulnerabilities and mitigation actions. So definitely this is something which the customer was following because the customer was still into the manual way of looking at the Tara. And the second pain point that the customer had was to build a robust cybersecurity management system, which would entail looking at frameworks and a baseline management system, which would entail that the customer would satisfy the standard ISO 21434 and ensure that they could build a robust cybersecurity system in place. So this is where we got engaged with the customer, and we started off with doing the planning. We deployed a team of 4 practitioners who would come in and look at the Tara for these ECUs. So obviously, because they had a backlog, so we had started off with prioritization of ECUs to ensure that we could pick up the ones which are more critical ECUs and which can have severe implications on the safety of the vehicle. So we did that exercise, picked up the most critical ECUs, and started the evolution of these ECUs. And when I say evolution, obviously it was all based on manual approach that we had, which Ron just now explained in terms of looking at all the components, policies, processes, and doing the Tara analysis manually. So alongside, a couple of team members also got engaged in terms of looking at the uplift from ISO 21434 perspective. So we were engaged in terms of looking at their policies, their processes, skill set, the technology solutions that the customer has deployed to ensure that we can look at all the facets of cybersecurity and can look at it from 360-degree perspective and provide holistic approach to ensure that we uplift the operations. So the customer also wanted us to look at the cybersecurity case, prepare the Tara report, look at supply chain activities, and prepare the related processes. So this is where we did these exercises wherein we conducted a holistic assessment based on 21434 to uncover security gaps for the customer. So if you can move on to the next slide, Ron. So after we carried out this exercise for the customer, so obviously the customer was able to have clear outcomes and gain in terms of both business perspective and financial perspective. So first and the foremost is they were able to get a very clear view of what are the gaps that they currently had, both from people, process, and technology perspective with respect to compliance to 21434. And not only that, I think as I talked about, so we gave them a holistic view of all the security issues that they had. So which gave them a clear view in terms of what are their short-term, medium-term, and long-term aspirations, and what kind of investment they need to make, both from people, process, and technology perspective to ensure that they can uplift their cybersecurity operations. And apart from that, obviously, because we did the Tara analysis for those ECUs, the client was able to get a comprehensive view of threats applicable to the ECUs and what was the underlying risk, so that they can prioritize the recommendation and obviously minimize the risk to the business operations. So definitely from a business value perspective, the first and the foremost thing was to reduction in the backlog which the customer had for so many ECUs which were lying down without threat analysis done. Apart from that, they were able to uplift their cybersecurity posture and ensure that they had robust processes documented so that they can comply to ISO 21434. So I think these were some of the things that we carried out for the customer so that they can uplift their security posture. And talking about this case study, so obviously the main thing that we wanted to highlight here is that this is still real world challenges wherein actual customers, whether we are talking about OEMs and tier ones, they are facing these challenges. And obviously, if you say the manual approach is where I think we took so much of our time because we spent almost 3 to 4 months with this customer fixing this problem. And if we can switch gears and adopt the automated way of conducting the Tara analysis, so we can get these done, get these Taras out within a period of 1 or 2 days. So I think that is the scale that we're talking about today. And my colleague Ron will talk about how we can scale this in an automated fashion. Ron?
Thank you, Akhilesh, for those insights from the real world and not only talking about theory. So to summarize, what are the challenges in the traditional approach. We can see the challenges in all the development stages, but we will focus on the design. First of all, for doing such processes, as Akhilesh said, we need a lot of cyber experts, and we are using those time for doing such processes that can be automated. And by automating those, we can free off their time to do more sophisticated tasks and research for more things that are not yet automated in the different development cycle. Most of the time, we don't have a synchronization between the Tara and the cyber design and the other system design. Once the system design is changed, we need to, the expert needs to take a look, understand what the differences are, and then update the Tara accordingly over and over again. And it needs to be notified that there was a change, and we need to allocate more time and to delay the process of doing those changes and updates. And after we did those, managing the version of those reports and the changes is even more difficult than than the regular way we are used to manage changes and track history like we are doing in software, for example. In software development, this is another change. We are just saving copies of the file and things like that. So how can we tackle those issues when we are talking about automated solution for performing Tara? So the goal is to address all the different stages of creating the Tara and the cybersecurity concept, and to do it with the control and overseeing and validation of the security expert. We want him to understand what is happening and to be in control of the system. We are not replacing him, we are helping him to do the things more efficiently. So the tool or the automated tool is connected to the requirements tool, to the HAL report, also to the company risk management policy that needs to be configured, and also to the design files and design tools that are used, like Enterprise Architect or things like that. They are an input to the process using AI to analyze those, together with a threats, attack path, and risk database, and also mitigation database. So it's not like AI is doing all. There is a need for a combination of threats and attack path information that was analyzed by experts for each one of the components. And based on that, with the combination of the AI that understand the relevant context of the system that we are analyzing, we can create the Tara and the cyber requirements automatically. So looking into more how we are implementing those, here in Plaxidity, we created a platform that is supporting all the processes of the development, from the design with the security auto designer, which we are going to see a demo of it in a few minutes. For coding, we have our code security manager looking into vulnerabilities in the source code while we develop it, saving time fixing those later. When we are doing integration and also operation, we have our software supply chain security, monitoring for vulnerabilities from binaries with SBOM, and this is important when you get binaries from suppliers, and also to monitor that during the lifetime, because new vulnerabilities are always being discovered. And for testing, we have our security auto tester automating different cybersecurity testing from fuzzing to some pen testing, and by that we are able to support all the software development lifecycle from the cyber perspective. And of course, with our platform, we are able to connect to the different tools used by the customers and to integrate into their regular way of work. So what will be the security auto designer process flow? First of all, as I mentioned, is to connect to the design file requirements, also to the vulnerabilities and to the HARA. And in some parts, it's bidirectional connection, because if I created cybersecurity requirements after I got the regular system requirements. I would like to update them in the same place that the regular requirements are being kept and managed, because cyber requirements should be treated as regular requirements in automatic way, as well as the vulnerabilities. Once we identify vulnerabilities, by matching that automatically to the relevant risk, we can know how we want to treat in this vulnerability and what the impact of that. So all these systems work in harmony to automate this process. And now we're going to see the demo of the system. Just a second. So here we can see a block diagram that we created of a simple architecture. We just loaded it before the demo. We can see an IVI that is placed in the center, communicating with Wi-Fi device over Ethernet, and with a camera model over USB, and with the main gateway of the vehicle via Ethernet, and also with an EEPROM via SPI. Of course, this is just an example. After that, we can see that the DFD is not yet created, as well as the TAR report, and of course also the cybersecurity concept. Now we will generate DFD based on that block diagram. And we can see the DFD that was created containing the different components that we've seen before, where once we click on one of the components, we can see our AI categorize those. In this case, it's Ethernet switch. And of course, if there is a mistake, that can be fixed from our asset catalogs already containing analyzed components with analyzed threat and attack path. Again, for the technology, for the connection between the model, here it's ASPI, as we can see, but another categories can be chosen. And we can see that we duplicated the connection because they were bidirectional, and we need to analyze the threat for each direction of the traffic. We can also add boundaries to define what is the boundary of the system we would like to choose. In this case, we won't do the analysis of the main gateway. Once we place that boundary, we will save the DFD and hit the generate TAR button. Now we generated the TAR. We can see the asset again, and that we generated 102 threats. We can see their assets and the threat itself and the threat category by the stripe method. For each one of them, we can click on them and see the most severe damages attached to them. Currently, we can see that this one is empty because in that version of the demo, we still need to add the damages manually. That's what we are going to do now. We'll go to the damage scenario section, hit add new, choose the relevant asset that we would like to do the analysis on, write the damage scenario. In this case, it will be not working just for this demo. Choose what is the cybersecurity properties that is being increased because of that, in this case, availability and integrity, and then give the impact rating in safety, finance, operational, and privacy. And of course, we can also add a justification explaining in free text why we chose this scoring. Now we will add this one, go back to the threat, go back to the same threat, and we can see that the most severe damage was attached to the relevant threat. Now let's go to the attack path. We have a 192 attack path automatically generated from the threats we've seen before. For each one of them, we can click, see the relevant threat and the different attack path steps for producing this attack, and also the attack feasibility assessment, again generated automatically based on our expert knowledge in our database. You can see the elapsed time needed, the window of opportunity, and based on that information, the attack feasibility that was automatically calculated. Of course, the expert can edit those fields, and by that we will again calculate automatically the attack feasibility. And again, we can add here justification. After that, we will go to the risk section. We can see that for the risk that there is damage scenario attached to them, we already have the risk scoring. Now we will hit one of them, for example. We will hit this one. We can see the risk value, the threat attached to that, and also the damage impact rating with the damage text and the attack path that is attached here. Now let's choose what is the treatment option for that risk. Here we will hit risk reduction. And then we will be able to export the report. So what are the main benefits of the automated way? First of all, we have faster time to market. We get better product cybersecurity because we have a standardized way to do those things and have more time to research for more issues. And of course, we make sure that we always comply with the cybersecurity regulation and standard because we always have updated data, even when from the first day when we have initial design, where we can update it later. Now, Akhilesh, I think it's time for you to explain us where you are coming from and have this extensive knowledge.
Sure, Ran, thanks for the demo. So just to introduce the two companies and the partnership. So I'm sure some of you may have already heard about the Mahindra Group. So it's a 80-year-old organization. It's a Indian multinational organization headquartered in Mumbai. So we have a history of which is expanding 80 years. And Mahindra is one of our prominent brands, and it is there into all the automotive cars that you see in terms of both commercial vehicles and personal vehicles, Mahindra racing cars. So essentially, if I talk about Mahindra Group, so automotive sector is part of our core DNA, and we have 260,000 employees across the globe. We operate across 100 plus countries and 22 plus industries. So if you can move on to the next slide. So Tech Mahindra is part of the Mahindra Group. And as I pointed out, so obviously we do a lot of work with respect to system integration and consulting. And we have 150,000 associates across the globe. And again, we have a history of close to 40 years in terms of operations. And if I talk about the full-fledged services that Tech Mahindra provides, so we provide services right from engineering to business services consulting, to infrastructure services, to sustainability, to data, AI, cybersecurity services, network services, application development. And we have achieved this growth both from organic and inorganic ways. So definitely you see a lot of acquisitions on the left-hand side in terms of Bond, Zentech, Bio, and all these organizations that we have acquired over a period of time to strengthen our automotive heritage. So obviously, if you look into the industries that we cater to, so you will see almost a mix of all the industries that we provide services to. But as I talked about, so automotive is our core DNA. And in fact, we work with customers across the globe in terms of automotive, where you talk about OEMs and tier ones, right from Packard to Bentley, Nissan, Navistar, BMW, Volvo, and the list can go on. And we are involved with these kind of customers in terms of next generation work with respect to designing their connected vehicle platform. We are doing work with respect to cabins of the future. We are doing work with respect to vehicle tracing and tracking. We are designing platforms for connected vehicles. We are doing work with respect to software-defined vehicles, vehicle data monetization, cloud FinOps, and extended reality, virtual reality as well. And the list can go on. So essentially, we are there if you talk about automotives. So Tech Mahindra is a very strong player when it comes to automotive cybersecurity. So over to you, Ron.
Thank you, Akhilesh. So I'm coming from PlaxidityX, company focused on specifically on automotive cybersecurity. This is our business. We're already protecting more than 72 million vehicles with over 100 customers. We are having global presence in all the locations that mainly vehicles are produced, from Korea, Japan, Germany, France, the US, with headquarters in Israel. We have more than 80 granted and pending patents, again, related only for automotive cybersecurity, with end-to-end solution, which we're going to see in a moment, and with partnership with all the industry leading players, starting from Microsoft, DSpace, AWS, and NXP, for example. And when we are talking about end-to-end solution, today we discussed about just one pillar from our portfolio, the DevSecOps, helping the development and operation cycle. We have also solution for in-vehicle, protecting the different kinds of ECU, from host protection to Ethernet protection, and also CAN protection, complying with the different in-vehicle regulations. We have our fleet solution, our PlaxidityX XDR, providing extended detection and response from the cybersecurity perspective to vehicle fleets. And our newest addition, our theft prevention section with our VDOM, helping in real time to prevent cyber-related vehicle theft and providing anti-theft protection. And one of the pillars is our services department, with our research group that helps to bring new cybersecurity insights and knowledge, and providing different services to customers, from cybersecurity compliance to helping with creating cybersecurity architecture, doing testing like vehicle pen testing, component pen testing, and also helping with cybersecurity engineering.